Good afternoon. My name is Schendowich. I'm a Hematology and Oncology Fellow at MedStar, Georgetown University Hospital. Today, I'll be reviewing large language models and how systems like OpenEvidence are being used in medicine. The goal of this talk is not to promote any single product, but to improve physician AI literacy. We're going to explore what these tools are, how they generate answers, where they help, and where they still require verification. So I'll start with the basics of large language models, then explain why medicine is a difficult domain for them. From there, I'll introduce retrieval-augmented generation, or RAG, and why it's important for clinical evidence. We'll then discuss benchmarks, use OpenEvidence as a case example, and end with practical questions on how clinicians should use these tools. So there has been a rapid revolution within medicine over the past few years. 3 years ago, when we had a clinical question, we searched PubMed, up-to-date, national guidelines like NCCN, and we reviewed the evidence and formulated a plan. Today, clinical AI can retrieve and organize much of the information for us. However, with these new tools, the physician's responsibility has also expanded. We now have to evaluate not only the evidence, but also the AI system presenting it. So evaluating these tools is becoming an essential clinical skill, one that's not really taught in medical school, yet physicians are increasingly expected to perform. So before we can evaluate an AI system, we need to understand what kind of AI it is. So we often use the term AI as if it refers to a single technology, but in reality, there's many different types of AI, each with different capabilities and risks. So artificial intelligence is the broadest category. Within artificial intelligence, you have machine learning, which uses data to identify patterns and predictions. Within machine learning, you have deep learning, and that uses multi-layer neural networks to learn complex relationships or patterns. And then within deep learning, you have generative AI, which goes a step further by producing new content like text or images. Large language models are generative AI systems trained on language. A key point for physicians to realize is that the LLM is the language engine, but products like OpenEvidence or up-to-date AI are broader clinical AI systems built around that engine. So now let's take a look at how an LLM actually works. And at a high level, there's really two key processes, the training and the generation. So during training, an LLM learns by predicting what comes next. For example, when an LLM sees the phrase HER2-positive breast cancer is treated with blank, it uses patterns from large amount of text to predict what is the most likely next word. By repeating this task across enormous texts of training data and documents, the model can actually learn complex relationships between concepts. So in this example, it learns that HER2-positive breast cancer is associated with the treatment trastuzumab. These are not stored as a separate fact, but it is instead a learned pattern that shapes and molds the future prediction of the model. So when we enter a prompt, the model uses those learned patterns to generate a response. So as shown on the right, it assigns a probability to the next predicted word or token, and it adds it in a sequence. And then that basically just repeats itself several times. So the basic mechanism is used in both training and generation, predicting the next token or word. That is why an LLM can produce clinically plausible language without functioning like a medical knowledge database. Now that we've gone over the basic idea of next token prediction, we can look inside the process and see why it matters clinically. So let's use the example shown below, which is how is EGFR mutated non-small cell lung cancer treated? The model first breaks the questions into tokens, and each token is then converted into an embedding. And what this is a numerical representation that allows a model to process the meaning between relationships and concepts. And those embeddings are then passed through something that's called a transformer, which allows or it analyzes how these tokens relate to one another. So basically, the model recognizes that EGFR, non-small cell lung cancer, and treated, those two specific phrases are connected, and that the question is asking about therapy for a specific molecular subtype of lung cancer. The model then assigns a probability to the next possible token. It selects one, adds it to the sequence, and like we said before, it just repeats this process over and over again. Clinically, this kind of creates several important limitations. First, the output is probabilistic. That means that it produces a likely continuation, not necessarily the most correct one. It is context sensitive, so the response may depend on the specific prompt that you use or that you enter into it. And in this specific case, the prompt included specific EGFR mutation. You can add potential disease stage or prior therapy or even resistance mechanism. Those are all context that may change the output of this specific LLM. It can also hallucinate. And what that means is that it provides or produces information that sounds plausible, but is incorrect or unsupported. And because of that, because of all of these considerations, it needs verification before it's used in patient care. So, there's really four main challenges for LLMs in medicine. The first is that, medical knowledge is distributed across several different sources. The second is that evidence is continuously changing and updated. There's always new treatments for specific cancer subtypes, and it's constantly being updated. The third is that the patient context changes by case. So a treatment question may depend on the stage, mutation subtype, comorbidity, and also patient preference as well. The fourth is that errors have significant clinical consequences. So it's a very high-risk environment for these tools to be deployed in. The key point is that medicine turns LLM from a useful language tool into a trust challenge. The output must be accurate, current, evident, linked, and applicable to the patient in front of us. So once we understand these limitations, you have to understand the base model and the product that is built around them. So the base LLM is the underlying language generation model. It processes text and predicts what comes next, but it is not the complete user-facing application. You really could think of it like a car engine. If you just have the engine itself, it doesn't necessarily do what you want it to do, which is transportation. ChatGPT is a general purpose system built around an LLM. It adds many different types of tools, a conversational interface, and also safety controls. You can consider this to be the complete car. The engine, steering wheel, the controls, the dashboard, it's all together. It's the complete package. When you look at OpenEvidence, it is a clinical evidence system. It combines a language model with medical evidence retrieval, citation, and a clinical interface. You can think of this as a specialized vehicle, like an ambulance, specifically equipped for focused, high-stakes purpose. The key point is that we should not evaluate these systems based on the underlying LLM. Their capability and their trustworthiness depend on everything that is built around the model themselves. For specifically OpenEvidence in many clinical AI systems, they use something called a retrieval-augmented generation, or RAG. And instead of relying on what the LLM has learned during training, RAG first finds relevant evidence and then it gives it to the LLM to help generate an answer. So the process has three main parts. And the first is building the knowledge base. And that's done in advance before you enter the prompt. And really, the system starts with a selected, curated source of documents, such as papers, guidelines, and web sources. So, for example, this could be all articles that are published in New England Journal of Medicine since 2010. These documents are split into smaller passages or chunks, and each is converted into an embedding, which is, as we said before, a numerical representation of what it means. It's stored in a database, we call it a vector database, and this creates a searchable evidence index, a curated one. Then, when a clinician asks a question, The retrieval engine finds the most relevant evidence and sends those top passages to the language model. Then, lastly, the generation layer produces the response. So an LLM receives both the clinical question and the retrieved passages. It then organizes and explains the information, ideally with citations that link to the original source, like OpenEvidence does. And the key distinction or the key part to consider is that the LLM still generates language, but RAG supplies the evidence first. It does not replace the LLM, it grounds the LLM with selected source documents. So let's go into OpenEvidence a little bit further. So a lot of what OpenEvidence is actually hidden. It's proprietary knowledge, but from the best description that I could find online is that it is a RAG-based clinical AI platform built around an LLM. So in practice, that means is that it retrieves current medical literature, synthesizes that evidence into a readable response, and provides citations that the clinician can review. It is also expanding beyond just question answering into areas such as guideline synthesis, visit transcription, patient communication, trial matching, and also administrative support. So it's really kind of pushing beyond just simple question and answers. But it is equally important to be clear about what it is not. And it is not simply a standalone LLM or a ChatGPT for medicine. And its internal architecture is not 100% transparent. It also does not guarantee that every relevant source will be retrieved or interpreted correctly. So what does this mean for physicians? Why should we care? Physicians need to care because the system may help us find and synthesize evidence more efficiently, but it does not take over the clinical decision. And when you actually look at the model architecture or the inferred model architecture, you can split it up into 3 different layers. And this is the best guess of how OpenEvidence is actually structured. On the left, you'll have the 3 layers: the evidence sources, the proprietary technical component, and the clinician-facing workflow. So think of it in those 3 layers. On the right side, you can see the likely RAG process. So the system takes a clinical question, ranks the relevant passages, sends the top evidence to the LLM, and generates a response with citation. Again, the key component or the key point is that the final output depends not only on the LLM, but also on what evidence is available, what the retrieval system finds, and the evidence that is ranked. So the RAG does not necessarily make the model smarter. It gives the model selected evidence before it can respond. So we've discussed how these systems work and why their outputs require oversight. The next question is how do we evaluate if one system performs better than another? There's many different examples of clinical AI systems currently available, like UpToDate AI. You have Doximity, GPT, and you have OpenEvidence. But the way that we can evaluate or compare these models is with benchmarks and evaluations. So you can kind of think of benchmarks like board exams. They are designed to test one aspect of performance under a standardized condition. So passing the boards tells us something important, but it does not tell us whether someone is going to be a good physician or not. So an AI benchmark works the same way. There's 4 basic steps to constructing and using a benchmark. The first is to define the task. The second is to build the benchmark with specific questions or clinical cases. The third is to score the responses. And the fourth is to compare the specific models amongst themselves. So using the same questions and scoring criteria. Key point is that a benchmark tells us how a model performed on a specific task. It does not prove that the model is trustworthy in every clinical situation. So let's look at, now we understand how benchmarks work. We can apply that concept to a clinical AI system like OpenEvidence. On the left, you can see here that several models were benchmarked on exam-style medical knowledge, and OpenEvidence scored around 89.6%. You can see here that other general LLMs were also tested and compared against OpenEvidence. This was in an article that was published, I think, 2 months ago in Nature Medicine. And on the right, you can see a little bit of a different perspective, one from the clinician's standpoint. So not necessarily accuracy, but how does the physician interact with it? How is the physician evaluation of it? And you can see here across 5 specific or across several different domains, such as clarity, relevance, and evidence, for 5 specific primary care cases, how open evidence specifically performed. The key point is that benchmarks and clinical evaluations help us compare systems, and that accuracy alone is not enough. For clinical use, we need to consider a more comprehensive evaluation. And this leads me to my next, I would say, probably the most important slide of the presentation, and that is that there's a clear disconnect between how clinicians may experience open evidence and how the company defines the products in its terms of use. So clinically, it might feel like a decision support tool. It gives fast evidence-based responses, addresses specific, patient-specific concerns, and it can resemble like a curbside consultation. But legally, open evidence describes the service much more narrowly. It is for informational use. It is not diagnostic or therapeutic advice, and the clinician remains fully responsible for evaluating the information and making the treatment decision. So the key point is that the system may function like a clinical consult in practice, while in its terms, the responsibility is entirely placed on the physician. So that gap matters when we think about trust, oversight, and regulation. So again, key point is that the clinician is ultimately responsible, so the user. So that gap, or this gap, between how systems might be used and how responsibility is assigned leads to the practical question, what should physicians evaluate before trusting it? The answer is to assess the entire clinical AI system, not just one specific component, or not just the LLM. We should ask several questions, but 5 main questions are important. Where did the recommendation come from? Can I verify the evidence against standard of care? Does this apply to the patient in front of me? Could the system or the clinical system miss something important? And does the system fit safely into my workflow? And number 5, which is also very important, we also need to understand the governance behind it. Who selected the sources for it to be trained on, and how often is it being updated? Whether or not conflicts of interest are disclosed or commercial influences are affecting its recommendations. So the key point is that trustworthiness comes from evidence, architecture, workflow, and governance of the entire system, not just accuracy. So the safest framing is to use open evidence as an evidence assistant. It is useful for focused literature questions, guideline navigation, clinical trial awareness, comparing evidence, and generating hypotheses. It should not be used as a standalone treatment rule. A substitute for reading key citations. That's not exactly what this is. And it's not what intended it to be, or a replacement for clinical judgment. And I think that's the most important part. It is not a replacement for clinical judgment. So I would like to end the discussion with an example. I want to show you a use case of open evidence in action and show you what a typical response may look like, as well as maybe some of the limitations that we see in real time. So I'm just going to change the screen right now. So in this example, we see here open evidence in the user interface, and we could see it's basically a chat box. And you can see what question that I've entered. What is the first line therapy for metastatic EGFR exon 19 deletion non-small cell lung cancer? You can clearly see here the answers that it provides. For metastatic lung cancer, EGFR exon 19 deletion, it provides the 3 first-line categories: osimertinib, chemotherapy plus osimertinib, lazertinib, and amivantamab. And it also pulls up concurrently the guidelines from the NCCN. So you can clearly see here what recommendation it's giving and the source of where it's coming from. This is a link that you can actually click on as well. If you scroll down here, you can see how I further prompted the specific case. So I gave it even more specific information to get a more specific answer. So in a patient that is 90 years old and lives far from the infusion center, what is the best first-line therapy? And for this, it actually gave one specific output, which is osimertinib monotherapy is best first-line therapy for this patient. You could see how this could be confused or conflated with a clinic, like a official recommendation from, let's say a society or a guideline. This is a specific recommendation that it has drawn forth from specific citations, but this is, I would say, where you have to be the most careful, because if you see open evidence is giving you a specific treatment output, you really have to investigate why and compare it to your own clinical reasoning, because this is where things can become dangerous. When they're recommending a specific intervention, you have to understand why. The last thing that I'm going to mention here is that there's a new feature of open evidence is that they integrated something called evidence grade. This is not necessarily how confident the LLM output is. It's more an evaluation of the underlying evidence that is being retrieved for the output. So that is a new feature that they just recently added. It does not replace the clinician going into the actual literature itself and pulling the information by itself, but it does potentially augment it. A lot of these claims need to be evaluated with, real physician evaluation studies. But with that being said, I'm going to go back to our original presentation and open it up for questions. Before the presentation, did anybody already have an idea about how the architecture or how open evidence actually generates a response?
Yeah, I had a general idea. It's definitely provided some clarity, though.
Yeah.
I wasn't familiar with the RAG.
Yeah, and I think that's like pretty key, because if you look at, all these other models like up-to-date AI and some of the more ones that are going to be coming in the future, they're really relying on RAG pretty heavily, because it kind of helps, narrow it down the literature to kind of provide a more reliable evidence source. But it's still not necessarily just like a search engine. And there's so many different types of LLMs that it's really important to kind of consider the different types of structures. And also there's honestly different types of RAGs themselves. And this is really just a introduction or a skeleton preview of what is happening behind the scenes of these models. I expect them to become more intricate and to adjust the confidence of their outputs to kind of really reassure clinicians and the users that what they are getting as an output is clinically meaningful and true. But if you were to take away one thing, I think it's important for everybody to realize that you cannot just rely on the output of open evidence, because ultimately you are still legally responsible. And if the model errs, then the responsibility is still on your shoulders. Okay.
Louis,
yeah.
I have, sorry, a super quick question for you. Thank you for this talk. It's maybe more of a general education related question, but I think, so for all of us, we did our training at a time when, tools like this were not available. but I'm meeting med students almost every single day who are heavily relying on open evidence for their own learning. And so as these med students become residents and then later fellows, I feel like their dependence on things like AI and open evidence specifically is going to be increasing a lot. So I don't know if you've encountered trainees who are relying on AI a lot and how you educate them kind of to lean away from that. But just kind of wondering your thoughts in general.
Well, I think there's two things to consider. The first is that the entire landscape has changed very rapidly. Even since I just started my fellowship, it's completely changed, being that there's almost like 50% of people are using open evidence in such a short amount of time. So I would say that it's not necessarily as important to say that we should not be using the AI tools, but it should be more along the lines of how to responsibly use them and how to actually clinically evaluate them. Because just like any other clinical tool that we're exposed to, you have to understand the basics about what's going on to use it safely and correctly. Otherwise, you put yourself in, honestly at risk, both legally and also the patient at risk as well. But another way to think about it is that this is just part of AI physician literacy, and it's a brand new field that needs to be integrated into medical education and incorporated into people who are already practicing, because this tool was rapidly distributed to everybody without, I would say, people knowing what to do with it. What do you think? What is your perspective on it? Because I'm sure you have seen it as well.
Yeah, I mean, part of me asking too was thinking about just this year with the opportunity to lead a resident team, how I would want to advise them to use a tool like this. And I wanted to hear your thoughts because I don't really have a good answer right now. But I think the slide that you showed was pretty helpful for me to personally build like a framework of how to advise using AI and not using AI. And I guess it really does just come down to don't let open evidence be the final word. But I'm still kind of clarifying that, how I'd want to present that to my residents.
Yeah, I think you make a good point. How do you teach this to a class where it's easy, right? It's easy to just type in a prompt into a chat box and get an answer. It's harder to look up and verify the sources yourself. And, I think you can easily fall into the trap of just relying on the tool without thinking about it. And I think that's the part to emphasize, is that you really can't, this is not a substitute for clinical intuition or clinical decision making. It's just an augmentation tool.
I totally agree with you. And then part of kind of what I worry about is whether people who are heavily reliant on open evidence will even get the opportunity to develop that clinical judgment that we should, theoretically be using. Yeah, I wonder how that's going to go. But very interesting things to think about.
Yeah, and the benefit will be is that they will have started their training in the era of LLMs and open evidence. So in some aspects, they're going to be better trained to use these tools, but they have to do it responsibly, and they have to do it with an understanding of what they are using. So that's why, not everybody has to be a data scientist, not everybody has to be a computer scientist. But you have to understand the basics of what is actually happening. And so I think it would be important to incorporate some of that into their education, even early on, as a dedicated lecture is what I would say.
I'd also add to the residents that source verification is key with open evidence, because frequently it will pull, like if I type in a prompt in open evidence and I go to the source to look it up and try to find the language that it's pulling from, it will pull language out of context from certain studies. And it might not actually be totally applicable to what you were asking it. I mean, you could like kind of fudge it and see how it could be used as supporting, but it's not really like fundamentally evidence for what you were asking. So I think source verification for residents coming up using OpenAI is like critical, because it is, like Lewis said, just a language model, and it's pulling language from various sources, and it doesn't always appreciate the context of those sources. So
that's a good point. And Nidhi, what I would also think is, think about how you want the residents to use it, and think about what ways that you don't want to use it. You have to imagine and you have to recognize the barriers of and the cutoffs of what's an appropriate use and what's an inappropriate use. And then you communicate that to the residents as well. All right, guys, thank you very much for coming.